This is a trained decision tree. A decision tree is a model that makes predictions by asking a sequence of simple yes or no questions about the input. On the right, we see the input space. Every point has two values, x1 and x2. Now let us take one random point and see how the tree predicts its category. Here, the category is simply the color. The point we test has coordinates x1 equal to 6.2 and x2 equal to 5.7. To classify it, we send it through the tree. We start at the top. First question, is x1 smaller than 2.5? For our point, x1 is 6.2, so the answer is no, and we go left. Next question, is x2 greater than 2.9? For our point, x2 is 5.7, so the answer is yes, and we go right. Next question, is x1 smaller than 5.7? No, so we go left. Next question, is x1 smaller than 7.6? Yes, so we go right. Now the point lands in this leaf. This leaf is pink, so the tree predicts pink. But this path is not only valid for this one point, it describes a whole region of points that would answer the questions in exactly the same way. First, the tree keeps the part where x1 is not smaller than 2.5. Then it keeps the part where x2 is greater than 2.9. Then it keeps the part where x1 is not smaller than 5.7. And finally, it keeps the part where x1 is smaller than 7.6. That gives us one rectangle in the input space. And this rectangle belongs to the pink leaf. If we repeat this idea for every possible path through the tree, the whole input space gets divided into rectangles. Each rectangle corresponds to one leaf, and each rectangle gets the color of that leaf. But these rectangles depend completely on the questions we ask. If we change the thresholds, the decomposition changes as well. And also, it is not clear that the tree should have exactly this structure. We could ask more questions or fewer questions. It is also not clear whether the first question should be about x1 or about x2. So if we want to build this tree ourselves, how should we do it? Because in practice, we want to make good predictions on data, and often all we have is training data. So we want to find a tree that fits the training data well, but at the same time does not overfit to it. How we can construct such a tree from training data is what we will look at in the next video.